So here's an example of how a client might make use of our system by embedding a code like the one you see in their own application. This one in particular does 100 single byte comparisons followed by a comparison of two 16 kilobit strings that differ only in a single bit, as you see, and then prints out the result. And there are several reasons a user might want to do that. One of them is keeping their very top secret array of bees private, as well as the result of some computation away from a cloud. Another reason is also simply lacking the resources to do it, which is around 4 kilobytes of RAM in this example, as well as being very error sensitive. And now let's run this script through our preprocessor to produce the client.go Golang file that we're going to run in a moment. And as you can see, here it is, produced. Here's a side-by-side comparison of the input versus output. The Golang file includes the necessary libraries, invokes the registration action on top of the blockchain, starts the HTTP client, starts the threaded communication channels, and here's the user programs that more closely resembles the one on the right, except for the loop being unrolled with the correct parameters. Here's the last segment of the code, comparing the two 16 kilobit strings and printing out the result. This eval stub is taken from the VDCS library for two string operands. Here's a view of the locally deployed contract on top of the EOS blockchain with a blank user table, ready to receive registration requests from the servers that go up right now. As you can see, 4 servers registered successfully, announcing their processing power of 32,000 gates, ready to receive the client request, who's now gonna run the client.go Golang file that we generated a moment ago. As you can see, the client is already receiving the evaluation results for the 100 comparisons. So let's speed up through that. And as you can see in the background, garbling the larger example is already being done in parallel. And finally, we're through the 100 comparisons and pending the result of the last 16 kilobit comparisons. And finally, we have received the result, which is false. And this took 16 minutes. But remember that each of these evaluations required a cycle of 4 servers, but as you can see, there are only 4 servers in the demo, which puts them under very heavy load. So in a more lively setting, a more efficient distinct cycles would be created, basically balancing the loads between them and increasing efficiency. Also note that all of these nodes are running a large number of threads, all of them competing for CPU time on my machine, since I'm the one playing the roles of the client and the server. And that was it for our demo. So thank you for listening, and do you have any questions?